All right, everybody, we're going to get started. Good afternoon. My name is Erik. I'm the co-president of the Stanford Energy Club, and we're really glad to have you here today for the second event of the Energy-360, which is an initiative by the Stanford Energy Club, and our topic today is going to be on zero energy buildings. Just to let you know, for those who are joining us for the first time, the Stanford Energy Club is the largest student organization on campus that brings together students, professionals, and faculty from all disciplines and across all levels for communication and collaboration on energy. Energy-360, which started last spring, directly serves that purpose and is at the heart of the Energy Club mission. Because the aim of Energy-360 is to have one energy topic and target it from policy, business, and technology perspectives by bringing great panels like the panel that we have here today. So before we get started, the last thing that I want to say is that I really want to thank the team who have worked on this event today. I want to recognize specifically the SEC Vice President for General Initiatives, Sid Bundari, and the Energy-360 Committee Chair, Sayak, Energy, and the rest of the team who worked on this event. And now I'll pass it on to Sayak and Michael so they can introduce the topic and they can introduce our panel. I hope you enjoy.
Thank you, Karim. The topic of today's Energy-360 panel discussion is zero energy buildings, progress and roadblocks. With over 40% of today's energy consumption in US being on building performance and building HVAC systems, I think the prospect of a future where we can have buildings that consume no net energy at all seems to be a godsend opportunity to solve all our energy and climate change goals. But is it really possible, or is it too good to be true? Today we have a constellation of eminent panelists here from diverse backgrounds who will discuss this very topic and probably provide an answer to the final question, whether we will finally have a time when we don't have to pay our utilities bill. Thank you. With that, I give the floor to Mike.
Thank you, Sayak. So today our panelists come from backgrounds ranging from academia, industry, policy, and law, and the task of synthesizing all those disparate views into a coherent picture falls on the able shoulders of our panelist, Sarah Backhouse. Sarah's a TV host and producer and has lived in Sydney, London, and Los Angeles, where she has worked for a diverse array of broadcasters, including CNBC, BBC, PBS, Fine Living, Sci-Fi Channel, Discovery Channel, and Planet Green. She's also a member of the UN IREO Media Committee and recently hosted Al Gore's 24 Hours of Reality. She's the founder of and host of Future 360, which is a syndicated digital magazine show which attempts to explore clean tech and innovative green technology. So I'd like to hand it over to our moderator, Sarah.
Well, thank you. First, let me say what an honor it is to be here at Stanford University. I was so excited to receive the invitation. Thank you very much. And my father, who was an academic, was probably even more excited. So it feels like I left TV and come back to academia, so he's very pleased. I'm also really excited to be speaking about today's topic, zero energy buildings. We'll be exploring the roadblocks and possible solutions to find out if this indeed can become a reality. It was mentioned earlier that 40% right now is the energy that buildings, 40% is the amount of CO2 emissions that buildings currently generate. And obviously this figure is not sustainable. We need to think of smart ways to move to a more healthy, economically viable and environmentally friendly future, and buildings play a huge part in that by saving water, saving energy, and reducing CO2. So you may ask why green buildings and zero energy buildings are important. I think there are a lot of savings and benefits that abound from those things. We mentioned carbon, cost savings in energy and water, also operating costs, There's also the views of the occupants who have a better quality indoor air quality and more productivity by working in these clean, healthy, futuristic environments. So where are we right now? In the US, as far as new construction goes, LEED is actually up to 20% of new buildings, which is definitely a move in the right direction. Is it enough? We'll find out whether it is or not. Also, internationally, LEED is making huge steps as well. I was recently at Greenbuild in Toronto and attended the World Green Building Council Gala dinner and was very excited to see over 65 member countries represented there. So I think that green building is definitely becoming an issue and something that countries around the world are seeing as an important thing to embrace. As far as retrofits go, this is another area where green can be very important. And we've seen it in iconic buildings like the Empire State Building, which was recently retrofitted with a lot of interesting green technologies. The question is the scale and speed of this movement enough to really mitigate these big challenges that we are facing as a planet? And I think by speaking with our panelists today, we will find out whether this is or not. We'll also explore the concept of zero energy buildings. There are a lot of definitions, and I'm going to be very curious to hear from the panelists what their particular take on it is. And is it something that's actually attainable, or is it just pie in the sky? So by speaking with our panelists who have various backgrounds, I think they'll form a cohesive picture of zero energy buildings. And so without further ado, I will start introducing the panelists in turn, who will give short presentations. We'll then follow that by Q&A. And finally, we invite you to ask your questions. And hopefully, over the course of an hour, we will explore the topic and see what conclusions we come up with. So let me go ahead and introduce the first panelist, Tom Horan. Mr. Horan has been a practicing architect for over 30 years and has experience across the spectrum of architectural services, from custom residential to commercial, institutional, educational, non-profit, and federal government programs. He's worked with the IRS to develop work-at-home policy requirements and has frequent participation in the area of structure and functioning of the workplace. He was involved in the design of the recent new LEED Platinum, anticipated, office at NASA Ames. This is called Sustainability Base. It is a much heralded project where he was executed by AECOM as executive architect and engineer under Mr. Horan's overall responsibility. McDonough & Partners was a conceptual design architect working with AECOM, and the building was constructed by Swinterton Builders. So, Mr. Horan, would you like to go ahead and show your presentation?
Hello, everyone. Tom Brenden again is my name, and I'm going to talk about a topic that's going to use as a starting point the new sustainability base. I'm not going to talk in great detail about that. There's some time, first of all, but it is a LEED. It's actually we haven't actually got our plaque yet. We have to go through certain paperwork, but it's going to be comfortably a LEED Platinum building. And I thought, first of all, I'd just show you a few of the strategies we use to achieve that platinum. We have a I don't know if anybody's heard of Bloom Energy, but we have a 200 kilowatt Bloom box on site that is generating electricity extremely cleanly. That was a late addition to the plan. We use techniques, architectural techniques, such as a very thin floor plate. As you can see, this is okay. You see, this thin curved floor plate is 53 feet across with no columns. We've got an exoskeleton, so we have a clear span, meaning, and we have high floor plates, which means there's a lot of light that can come in, reducing the need for electric lighting. And we all have integrated a lighting system with the day lighting, so It's an extremely efficient system. We have a really interesting thing, which is a ground source heat pump. We've gone out in the Shenandoah Plaza across the way, which is the middle of the former Mock airfield. We drilled 140 or so 150-foot deep wells, which take advantage of the heat of the earth being a constant, more or less. So in the summertime we can cool the building, and in the winter we can heat it with that ground source. Again, photovoltaics and two kinds of photo systems. There's a hot water heating system, solar hot water, and then there's a photovoltaic system generating electricity. So these are, we've used a lot of these various strategies, and it's a complex, it's a brand new thing for NASA. You have such a complex building. This hall has to be integrated, and there's going to be a year of kind of testing this and shaking the bugs out of it. But what I'm here to talk about today, though, is what I see as a roadblock to energy, to achieving net zero energy. By the way, the name net zero has been associated with this building, and I always caution or insist that on these PR things that go out, that we put the word, either the word approaching, targeting, or trying, because that was never original goal of ours, but once a phrase gets associated with the building, people just assume it is. So it's not entirely net zero at this point. It is meant to be a platform for future research, however. So what I wanted to bring to your attention on this building, though, is our exterior fenestration, the window glazing. There's a lot of glass, and by golly, you can open it. And there are two rows of, there's an upper row which is motorized and a lower row which is occupant operated. The upper row is on sensors, and the lower row is going to take a bit of getting used to for the occupants, because they're not going to want to have the air conditioning, or in this case, chill panels distributing cool air and have the windows open and so forth. So this is and when we were doing the original planning for this building, we actually considered the idea of having no air conditioning. And we did a lot of modeling, a lot of study, and we came close, and it was a very tempting goal. And we determined that there would be 5 days in a given year that you would have to send people home in the heat of the afternoon because it would be too uncomfortable. And that was a situation we couldn't really justify. So that's the context for my thoughts. And my basic thought about this in net zero in the future is that the roadblock seems to be that we've got an addiction to mechanical cooling, or commonly known as air conditioning. And in our modern buildings, this results in very high energy use and results in habituation of the entire culture of truth to what is essentially a fairly alienating and not a pleasant workspace. My idea about how we can remove or get around this roadblock is, in a simple phrase, let the window be open. And we made the start here. When you open the window, you do all kinds of things. You make a connection to the natural environment through your ears, your nose, your eyes, even your skin as you feel breezes. This is a very important thing for human productivity and human enjoyment as well. When you start to open the windows, though, you create a conflict with air conditioning, and there are lots of systems that can be tried, and it hasn't really been perfected, and it may not be. But so my thought is that if we can come to a way of maybe pulling back and look at the whole workplace, what is the workplace made of? Why is it used as a model of sort of a factory floor with the executives on the mezzanine? Why don't we think of a model such as a village of artisans as opposed to a beehive? So this is just a very high-level way of stating this, but I thought this would be a good starting point for some of the discussions here. So, thank you.
Thanks, Tom. Our next speaker is Erik. He's the founder of Kolderup Consulting and faculty here at Stanford University. Mr. Kolderup provides technical consulting services focusing on sustainable, energy-efficient design and construction of commercial and institutional buildings. He employs computer simulation and other analysis methods to assist in the design of high-performance envelope lighting, daylighting, natural ventilation, and HVAC systems. Mr. Kolderup has served as consulting faculty member in Stanford University's CEE department, teaching a class on building systems from the spring of 2008 to 2011.
Thank you, Sarah. Yeah, so a plug. Those of you interested in building energy and net zero energy buildings, take a look at CEE 156 in spring. So I thought that I would just talk about a fundamental challenge that we face in creating net zero energy buildings, and maybe I'm stating the obvious here, but I thought I'd put some numbers to it. This is a very simple analysis that looks at the relationship between building height and the ability to make it net zero. If you go and do some research on the current net zero energy buildings that are out there in this country, what will you find about? What would be the unique or common characteristic to most of those buildings? They're one-story buildings. Maybe two-story buildings. Once you get to maybe two-story buildings, then they got to put PV over the parking lot to reach net zero. So what I've done is just put some numbers to that. If you take a state-of-the-art energy-efficient building and look at its energy demand, so it's got lots of the features that Tom was just talking about: daylighting, natural ventilation, extremely efficient lighting, all those kind of things. Then maybe you get this red line. This is starting with, just say, a typical office building, 10,000 square foot floor plate. As you stack up stories, right, you increase the energy use roughly linearly. That's the red line. If we look at the total solar potential that strikes that building, we look at the roof, we put PVs over all opaque wall surfaces. What's the total amount of energy that that building will receive in a year from the sun? The potential from the roof, obviously doesn't change as we make the building taller. That's about that much PV or energy that we can generate with the current technologies from that roof. And then as the wall area increases, obviously we can get somewhat more and more energy from the wall. But what does this tell us, right? If we're just putting PVs on the roof, and this is an extremely optimistic scenario because usually there's other stuff on the roof. So if we took the entire roof and covered it with good PVs, then maybe we could get up to about a two-story net zero building with an extremely efficient design, which is not the common design. And then, if we covered all the walls, we might be able to get up to 3 stories, right? So that's my fundamental back-of-the-envelope kind of calculation, and it's the challenge or the roadblock that's out there. So what do? We try to bring this red one down, right? Technology, better building operation, all those kinds of things. So some of you will hopefully be working on that in your futures. And then we try to bring these lines up, improve the conversion efficiency of renewable energy sources, technological kind of solutions. But I think ultimately, if we decide that net zero energy buildings are a priority in our society, then we're going to have to set up policy frameworks that will allow, say, dense urban buildings to do what they can at the building site and then contribute somehow to some sort of regional type of renewable energy production. That's just the basic physics. So I think I'll leave it at that and let the other panelists share their ideas.
Thanks, Erik. Next speaker is Notaney from Project Frog. Ash is the VP of Supply Chain at Project Frog, Inc. Project Frog is a company specializing in high-tech modular prefabricated construction methods that deliver energy-efficient buildings at lower costs in less time than traditional construction. Ash is a vital member of the Frog team, working to establish strategic relationships with key suppliers. He excels at optimizing the end-to-end value chain and inspiring a revolution in how buildings are constructed. Ash has an MBA from Columbia Business School and is an undergrad degree in economics from Cambridge University.
Thank you, Sarah.
I didn't know some of all those things about me. It's very, very complimentary. Let's talk about sort of zero energy buildings is very interesting. Zero energy, we've been speaking to a lot of clients about it. It's sort of a little bit of a marketing thing at this point because it's the thing that's out there. A few years ago, Leaf Patent was the thing to achieve, zero energy thing to achieve now. But I think what we'd like to see ultimately is the building can generate as much energy as possible out of its footprint. And to Erik's point, a very tall, very sort of deep building probably can't generate all its electricity. But if you're a short building, you're a one-story building, why stop at net zero where clearly there's enough potential in your facade and your roof to actually generate much more than that. To us, it's just about, environmental responsibility, and actually, you've got a building there, you're taking up space, let's actually do something with it. But, and I can talk a little bit about what we're doing, but I want to talk about the roadblocks and how we fundamentally approach it. So, the biggest problem with net zero or zero energy building, or fundamentally green, is economics. And when we look at this industry, we look at an industry that somehow the Industrial Revolution passed it by. This industry does not get greener, it does not get more efficient, it just sort of, it just creates its own complexity. And why is that? It's in this sort of doom loop, but it's not accidental. There's a reason for it. There is a huge amount of variety in this industry, and it starts from having different projects, different codes, different sites. Every project is unique to some extent, and because of that, there's an enormous amount of risk in this industry. The state of this industry exists really to manage risk. The entire fragmentation of the vertical supply chain between architects, structural engineers, mechanical engineers, daylighting consultants, lighting designers, general contractors, myriads of subcontractors, manufacturers. The reason this is all split up because projects are so big that no one wants to take it on and handle all that risk because they can't predict how it's going to turn out because everything's different. Every time you do something different, it's like, I've got to think about it. It could go wrong. I've got to protect myself. That has led to overheads being probably the biggest single cost of building. This is our own analysis. So, it's based on a particular building. So, I won't claim that that's applicable across the industry. But it's pretty clear to us that when you buy a building and you go back to that building, you live in that building for years, what you're actually left with is the materials, right? That's what actually fundamentally makes up your building and makes it worth living in, and that's what drives its energy costs. Yet most of what you paid to put that building in place was actually the overheads and the labor. And the labor was very inefficient because it's a bunch of craftsmen basically putting this together and figuring out what they've got. So we look at this, and we say, the way you get a better building is better materials. And the problem is the building's so expensive, and materials such a small part of it. To improve your materials, it just doesn't feel worthwhile, especially because the cost of energy is so low. So we look at it and say, you know what, let's look at that, that 70% of overhead labor, and say, if we can attack that, and attack it because you change that whole variability dynamic, that's where a lot of the savings can come from. Then you can invest in materials, and then you can get better buildings. And so how do you do that? So this is the way we think about it, and we could be totally wrong on this, but we're going to give it a go. We say not every building has to be unique. There are reasons that certain buildings will be. A museum needs to be sort of a unique item, or you have certain plots of land. But there is $400 billion of commercial construction in the U.S., and a lot of it is just a lot of it isn't even architect design. It's just buildings that are put up in place, and away they go. And so what we've been working on is a system of parts where it can give you a building with some variability. It's not an identical building every time, but it's almost like a Lego set, right? So you can create different things. But the idea is that those Lego pieces can be produced at scale. The way those pieces come together, those connections, are ones that are repeatable. So someone putting it together knows exactly what he's doing. It looks more like a factory when the building is actually assembled. And you're actually bringing down the fundamental cost of construction, all that inefficiency. And in doing so, when you design those pieces, you design better pieces from the beginning. So we're actually at a point now where we can pretty comfortably claim when we go out to our clients that we can give you a building for the same cost as you pay today, and it's 30% more energy efficient than code. But we think we're just at the beginning of this process because this whole idea of thinking about more of a smart customization approach to buildings, we think is the way to get past this roadblock of the economics getting in the way of green.
Great, thanks, Ash. Our next speaker is Brenden Millstein, CEO of Carbon Lighthouse and Stanford Energy Club. Brenden is co-founder and CEO of Carbon Lighthouse, which was formed to enable companies, educational institutions, and other organizations to profitably eliminate their carbon footprint by bundling 4 engineering services: efficiency, demand response, renewable energy, and carbon allowances into a single package. Brenden obtained an MBA from Stanford University's Graduate School of Business and an MS in Renewable Energy Engineering, also from Stanford.
Thanks, Sarah. Hey, so I'm Brenden. So Carbon Lighthouse makes it profitable for other organizations to eliminate their carbon footprint. So we've been talking a lot about net zero energy buildings. We go for net zero carbon buildings. And one of the things that I think is important to consider is that if you look at the carbon footprint of buildings, if you go out through about 2030, the general consensus is that existing buildings are going to have about 80% of the carbon footprint, and new construction will have about 20% of the carbon footprint in terms of the carbon impacts from buildings. So everyone else has been talking about designing new buildings. We're really focused on retrofitting existing buildings. And actually, Erik's slide was particularly interesting to me, of the amount of solar you could put on a building, on the roof, and then including the wall, and watching that line go way over it. So we work with large commercial and industrial buildings, and we find there's basically no way to move the needle with solar. So as soon as you get into a building that's 10 floors tall, you know, if you're trying to retrofit solar onto there, the roof is actually already mostly taken up by air conditioning equipment. So there's all this stuff on the roof, you can't put solar up there cost effectively, so we have a real problem. So basically what we do is we find ways to use energy efficiency to reduce the energy use of the building by about 20%. So I'll talk about this very briefly, but we can predict energy savings really, really, really well. So what you're looking at here is a graph of the predictions of, and this isn't a whole building, this is just an individual air handler. So this is basically an air conditioner that's could basically power about 20 houses. That's the size of this air conditioner. It's a really big box on the top of the roof, and there's a few of them up there. And so we modeled one of these units, and what you're looking at, the blue line, all the blue dots, that's our prediction for the energy use of this thing by the hour. And the black line is its actual use. So we can predict energy savings really well. So this is a big deal, because we can go to a building owner and say, hey, here's what we're going to do. We're going to do all of this stuff to your air conditioning system. We're going to add in some daylighting. We're going to replace a whole bunch of systems. It's going to save exactly this much money. And then we're going to use a small percent of that to compete with power plants for pollution permits. And so that's how we get people from, say, 20% carbon-free or 70% carbon-free to 100% carbon-free. So this should work. I can go to a building owner and say, look, it's going to cost $400,000. It'll save exactly $187,000 a year, increasing 3% per year or 5% per year with utility prices. You know, this is a really good financial investment. You should do it. And yet, it's incredibly difficult to convince anybody, well, pretty much to do anything, but more importantly, to do big, giant energy projects. And so this is one of the reasons I think it's so difficult. The y-axis here is the amount of money people, like a company, spends per square foot in their building. So the giant hulking thing is their employees, and on average that's going to be between $100 to $400 per square foot for a lot of corporations. Their rent could be, it really depends on where you are in the country. It could be anywhere from, say, $20 a square foot to, say, $100 a square foot. In Palo Alto, it could be like 40 or 60 bucks a square foot. Utilities in the Bay Area are like $2.50 a square foot. So they're literally 100 times less than what companies are spending on their employees. So this big hurdle is, hey, we can make all these predictions. We can say, look, we can get you to carbon-free. It's going to cost this much. It's going to save this much. And no one cares, because you have this incredible split between how much money companies are spending on their utilities and their energy, and how much money companies are spending on everything else that's important to them. So I wish I could say we figured out the solution to this roadblock towards zero carbon buildings. I'd be running a multi-billion-dollar company, not a 5-person startup. If we had, we're hiring, by the way. We figured it out a little. And so that solution that we figured out is you actually can't talk about the money, which is very surprising to me. So we started the company with the thesis, okay, we have this new way of predicting building energy use. That means we can predict costs and savings exactly. That should be enough, and it wasn't. So now what we do is we go to buildings and building owners and property management companies, and we say, hey, we can help you do the right thing for the world. And so we've sort of pivoted our marketing and our sales to really address the personal aspect of every single person we interact with and say, look, I know you want to do the right thing. You're a good person. Most people are good people. Let's figure out how to protect the country, protect the planet, and at the same time, we can save you a little bit of money in the process. And that little bit, it's little. It's that tiniest little slice on the left. But, you know, to help someone do the right thing, that can be enough. So that's sort of our proposed solution to it.
Thank you. Our final speaker is Heather Rosmarin. She's an associate at Cooley LLP. Heather Rosmarin is active in the firm's clean energy and technologies practice. She joined the firm in 2003 and is resident in the Palo Alto office. Her practice consists of general corporate and security law matters with an emphasis on representation of emerging companies, venture capital funds, and public companies in the technology sector. In addition, Ms. Rosmarin counsels clean energy companies on applying for federal grants and loans and related contractual and compliance matters. Her practice also includes advising for both for-profit and non-profit corporations on formation and governance matters.
Great, thank you, Sarah, and thank you to the Stanford Energy Club. It's a real honor to be here. Thank you. Why is an attorney on this panel? Because a lot of the obstacles to achieving energy-efficient buildings all the way to zero are somehow touching on legal or policy issues. So I want to focus on the financing piece of it, which several of the panelists have already addressed. Since retrofits, and we're talking about existing building stock, are generally capital intensive, there's an upfront cost barrier. Public financing is increasingly scarce, so the goal is to mobilize private capital. How do we do that? The challenge is that in the commercial context, as Brenden really effectively illustrated, tenants are not really incentivized to pay for these upgrades on a financial basis because the cost of the energy is passing on and fragmented across all the tenants. The landlord is not incentivized because the landlord is passing it down to the tenants. The existing third-party financing models that could be imported from other contexts raise accounting and tax issues, potentially, which makes people step back. On the residential side, if you have turnover in residential housing every 5 years or 10 years, an owner may be concerned about spending a lot up front to make an improvement that has a 20-year lifespan, but they're not going to be there in 5 years. So they won't realize the benefits. So to summarize, the roadblock is the lack of scalable financing solutions to retrofit existing residential and commercial buildings with renewable energy generation and energy efficiency technologies. The emphasis here is on the word scalable, because as Sarah said in her introductory comments, there are lots of ways to tailor solutions to every building. But if we're going to scale this up at the speed that's required to really address climate change, then we need to have these scalable financing solutions that can aggregate large amounts of capital and put them to work. So one potential solution that was developed here in California a few years ago is property assessed clean energy, PACE. So PACE is basically a policy or program adopted by a city that enables owners to upgrade buildings with no upfront costs, and this could be commercial or residential. How does that work? The investors come in with money, it's aggregated, and the owner can get a chunk of that money and pay it back over time, 5 to 20 years, through surcharges on their property tax bills. Those surcharges will be less, if all works out well, than the amount that they are realizing from energy savings. So this addresses several of the challenges. The repayment obligation, the benefits of the improvements transfer automatically to the next property owner. That's one of the key benefits. So that makes the investor/lender more comfortable, and obviously it's good to have it attached to the property rather than to the individual. Within 2 years, 24 states, about half the states in the country, passed PACE legislation enabling this to happen in their jurisdictions, which is, from a policy perspective, very rapid expansion. Then residential pace stalled because the Federal Housing Finance Agency last year put out a statement saying, we're not comfortable with these property tax surcharges because they could take, and in most cases would take priority over other liens on the property, such as mortgages. So this is an unanticipated obstacle to pace implementation. So, and I'm going to stop the daisy chain with just one more step, which is that the roadblock, the solution to the roadblock is Federal Housing Finance Agency statement, and the solution to that includes proposed legislation. And lots of people are trying to figure out how pace can go forward in residential context. On the commercial side, because FA doesn't have a dog in that game, commercial pace is moving forward. And some key examples are, last month, San Francisco launched a commercial pace program. And there's a consortium of startups and large companies and financiers that are planning to put, according to media reports, $650 million to work in municipalities across the country. And the first one that signed up is Miami, and apparently they're working on Sacramento. This is based on media reports, not on any client information. So that's the presentation. I look forward to the next phase of this discussion.
Thanks, Heather. Thank you to all the panelists for giving us an overview of the areas of expertise. I look forward to kind of doing a deep dive into each of those and getting more into the solutions. But for now, I thought I'd kick off the discussion with taking a step back and talking a little bit about zero energy buildings and what that means to everyone. So I'd like to ask each of the panelists in turn to give their backers and envelope brief definitions of what a zero energy building means to them. Erik, want to kick it off?
Yeah, sure. I guess I would defer to some work that's been done by the National Renewable Energy Lab. They've done some research on definitions for net zero energy buildings. They have a whole classification system, A, B, C, D. One is the case where you've got renewable, all the renewable is attached to the building. So within the building footprint, you're generating the energy you need to power that building. And then they have a not quite as good category where, okay, you put PV on the parking lot. And then they have successive categories. So I think there are lots of definitions out there, and it's something that as an industry we need to work forward to a consensus on. But for those of you interested in definitions, I suggest you look at the NRL.
I would just add, yeah, it's a good starting point might be to say, let's make it a property line, whatever happens within the property line and count, but as Erik mentioned, that might not be the definition of it.
So I think it's less obvious how to define things in a net zero energy building or a net zero carbon building than one would imagine. So I actually want to explain a little bit why it's complicated. So one of the things Erik's presentation showed, I think that was pretty good, was that if you have a shorter kind of squatter building, it's actually easier to make that net zero energy. But you can imagine now if you have a whole city of those, it's going to be much, much more spread out, and so everyone's going to be driving around and taking a bus or some method of transportation that gets there. So where you draw the box, be it around the building or around the property or around the city, is not super obvious. And it gets even more complicated when you start looking at the carbon impact and not just the energy use. And so one of the ways we do it at Carbon Lighthouse is we define it around the fuel, so primary or secondary fuel. So if you have to buy electricity or if you have to buy natural gas, that's not net zero energy to us, and certainly not net zero carbon. And so the way we define things is whoever buys the fuel, that's their carbon footprint, that is their energy footprint. But this it can't just be that simple, right? So if you're a resident and you drive to the Google office, I would define that driving as your personal carbon footprint because you bought the gas for the car. But on the other hand, if you take the Google bus, that would be Google's carbon footprint because Google bought the fuel for the bus. But this is a little bit twisted, because if you take the bus, you increase Google's carbon footprint, but you're really decreasing the total carbon footprint, because a bus is much more efficient than a car. So like, how you define the box is really complicated. Like with an airliner, do you blame the airline for its entire carbon footprint, or do you break that up based on passenger miles? So I think there's reason NREL has done actual research, and that you need to really think carefully about things, because it's not a simple problem. But I would say the way we do it is we say whoever buys the fuel, that's their carbon footprint, that's their energy footprint, with the exception of sort of transportation. So if you take public transportation, or if you take an airline, we would count that as your carbon footprint, not the airline's energy footprint.
Yeah, thank you for drawing in the transportation angle. I think that's a factor to measure. Ash?
Yeah, I mean, I think what the panelists have said is exactly right. It's a complicated answer based on definition. We're in the market of trying to sell buildings. We keep it pretty simple. Basically, it's grid neutral within the footprint of the building. And that's something, if you can do that, then basically you've got no electricity bill. There's a sort of a psychological benefit of that. I think that's what we basically, we encourage our clients to get that. We don't try and say, hey, you don't need to go any further, but that's almost like a sort of benchmark we're looking for.
I just second that, saying anything we come up with being conceptually clear would be a strong benefit. And that's the big benefit.
I have nothing to add. I'll let the technical experts define zero energy buildings.
Okay, very good. Well, I think we've got the definition addressed there. I guess now I'd like to talk about, is it an attainable goal? You mentioned some buildings, I think it was Erik, that have attained net zero. What percentage of buildings are there, and how likely is it for other buildings to get there?
Well, I guess everybody can probably address that. As far as percentage, it doesn't show up either. We're talking about a dozen buildings, perhaps, so maybe some other stuff.
It's a goal.
It's a small number, and it's driven by building owners who are committed to making a statement at this point. So it's economically a difficult thing to do currently.
Tom, this might be my question over for you, because obviously you're designing this sustainability base. I mean, you have pretty much covered every angle of sustainability in this building.
We tried.
And surely a number of challenges and issues have arisen with that. You mentioned the air conditioning, but...
Well, yeah, I think one of the challenges that's more immediate than that even is the complexity of all the systems we have put in here in order to take advantage of all the strategies we use. I mean, there are 600 different so-called points of control that have to set back to a central computer, and such things as the daylight sensors, which control the lighting, and thermal blinds, which come down when the sun hits them, and the windows which open and close based on programmatic information. You got to make sure, for example, that you're not eliminating daylighting by turning the blinds down and also making the natural ventilation come through the window at the same time and effective. It's a challenge that's far beyond the expertise of typical building engineers. So we're going to keep breaking people in over the next year at NASA to help them along in this big culture cost.
What are some of the best practices you think you can share based on your work with that building?
Wow. Well, we did a lot of modeling, but I don't think we could have done more modeling in terms of development. We had a very, working within the federal government is an interesting place to work. Funding, availability of funding drives a lot of decisions. It's all fiscal year based, and if it doesn't get spent by a certain amount of time, it goes away, which makes everyone very unhappy. And so some of the schedule issues drove some of the decisions because there just wasn't time to study certain things. So I think a more considered approach going in would have made it more few possible pickups from the road.
Heather, speaking of financing, you've done a deep dive into case and found that as a viable solution for people looking to get financing for their buildings. Is that the only alternative? Are there others, or do you think that's really the best?
solution for people out there?
Well, I hesitate to say that I think one solution is better than others. I think this is one that, based on market response, in terms of how many states have adopted it and how much enthusiasm there is, and the types of stakeholders that have really signed on to it, this one clearly has a lot of potential. I think that the flip side of the bad news that was articulated, namely, not very few buildings are currently, highly energy efficient, is that there's opportunity there to, access a huge market of building stock that could be made more efficient. And that one of the key challenges here, which CASE is trying to address, but there could be a better solution out there, is to aggregate private capital and figure out ways to make energy efficiency and renewable energy retrofits investor friendly. And so we have any MBA students and econ students, and we've got one here who's already got a good solution. He's got a good solution that is being scaled up as we speak. But we need, I think, a lot more folks who are very sophisticated about finance to get involved in this and to look at it and to listen to all the folks who are working day to day on these buildings, working day to day with property owners and investors, and to really break down and analyze what are the blocks, and given their knowledge of what the financial markets will be responsive to, how do you design those types of instruments that will raise capital and deploy it in the sector.
Thank you. Brenden, I was interested, in your presentation, was curious that you kind of steered away from the bottom line, green, money, and went more to the sustainability angle and asking people to do the right thing. It's a really innovative approach, and one that may seem obvious, but kind of a hard sell, I would have thought. But I'm interested to find out how it's been, that new message.
Yeah, easy, which is why we switched to it. So we started the company just talking about the dollars, and it's, first of all, everyone's trying to sell you something, so no one wants to hear another pitch about how they're going to save all this money about pumps and motors and ductwork that they don't even know exist in their building. Like, there's 400 companies trying to convince people to replace their motors, there's 1,000 companies trying to replace their lights. And then there's a real problem, which is, a good portion of those companies are doing really fantastic work, and then there's also a portion that's not really acting in the interest of their customers, I'll put it that way. So to go and try and sell people on the money and the savings is a very difficult pitch, because it's a small amount of dollars overall. And I think one of the things Heather is talking about is that, if you remember that chart with sort of the $2.50, per square foot, that's not so interesting to one building owner, but if you can aggregate 100 of those things up and then sell it to someone, a third-party person, now it's more interesting. If you do it 1,000 times, it's more interesting, and that's what CASE is trying to do. We're not at that level as a startup. We don't have 1,000 buildings which we can aggregate together. We launched last year and we finished 60 projects, so we're not at a place in the company where we can really aggregate that up and sell it to a city. So we've had to go with a more marketing strategy of sitting down one-on-one with someone in a sales meeting and being like, look, we can do a good thing for the world here. We'll save you $40,000. It's nothing to write home to mom about. If you happen to be AOL, or if you're AOL, we could probably save you hundreds of thousands of dollars, but that would still be nothing to write home to mom about. But whoever's on the other side of that table, you want to do the right thing. And hey, it's going to save a little bit of money. So we switched to that midway after trying to pitch AOL and saving $100,000 like 25,000 other companies have pitched that. And as soon as we switched to just talking about the normal person, everybody signed up. So that was sort of this whole
Like you're saying, we'll pay you to do it.
Yeah, exactly.
I guess it's in keeping
In fact, said exactly that.
I would just kind of echoes Brendan's comments there. If people are trying to market this kind of stuff, I found in the days pre-LEED, doing energy efficiency consulting, I'd walk into an owner's office and say, we figured out for this extra $100,000 investment, you can save $50,000 a year. It pays back in 2 years. Show me an investment that's better than that. And they say, oh, well, I don't know if I have the money. And then LEED came around, and we said, okay, for this $100,000, you get 3 LEED points. And they said, all right, I see that. And they had a bigger goal, which was LEED. And it can work in the net zero context too, where net zero is something hard to attain, but it's a goal that we can define, and getting there has some extra value beyond the directed value.
Well, that's a happy finding and a positive one about kind of goodness of mankind and, you know, our innate need to want to be the right Ash, I want to touch on your comments earlier in your presentation. You talked about variety kind of being the killer of sustainability and how uniformity you can reap these efficiencies. Is that why Project Frog opted for the kind of modular approach? Is that how you managed to do the right thing at a less cost?
Yeah, that's actually the key to it. So be able to sort of reduce the number of variables, sort of simplify the approach, take a big chunk of cost out. That's really the approach to doing that. And you know, the comment that we always get here is, well, you can't make the same building again. And the truth is, well, you don't, because it's a very interesting problem actually. So if you look at cars, right? Now, most of you know, right? The cars are built off of, you know, many cars are built off the same platforms. You have 4, 5, 6 different models, and that model has lots of variation. And yet people say, well, the car looks the same. Well, that's old manufacturing technology. That's analog manufacturing technology. If you look at the variety you get in digital technologies now, so an iPhone is a great example. You have a common platform, the iOS, on top of which apps appear. And those apps actually give your iPhone all these different capabilities, and it's this idea of digitally customization. That manufacturing technology is starting to exist, it's starting to scale, where there are digital manufacturing technologies where you can make pretty massive changes to the things that you're making, and it doesn't affect the production of the line. And you can keep several details the same, and so when it goes to the site, it looks familiar. So it's things like that that we're really trying to leverage, which is actually a lot of things that aren't, you know, people aren't even using in construction. We're sort of looking to other industries, say, what can you pull across? So we do think that it's about reducing the complexities, really, and that doesn't necessarily mean that the buildings don't all end up looking all the same.
I think that's interesting, the move from analog to digital, which every industry is facing in rebuilding, being no exception. Do you think that inherently mines out a lot of the inefficiencies, and is that going to be a game changer for rebuilding as a whole?
Well, I have a thought on this. So Ash is being a little bit humble here. The amount of overhead and labor the system will be able to reduce is really incredible. So we get bids for projects, and so sometimes we'll want to run new ductwork somewhere to enable a building to take more outside air in instead of just, you know, if it's 60 degrees outside, there's no reason to be running the air conditioner, you should have the windows open. And so what do you do if the windows don't open? Well, you don't replace all the windows, but sometimes we can at least enable the building to turn off the air conditioner and just suck in fresh air from the outside at the air conditioner. So when we get quotes to do this, the sheet metal guys, and so these are one of the, you know, hundreds of different contractors who will work on buildings construction, they'll give us a quote. That quote will be based, they'll kind of look at the drawings, you know, like where the sheet metal needs to go, and then they'll figure out how much they think the sheet metal will weigh, and then they multiply like that weight by $1 per pound of sheet metal, and then they have some pretty random factor, which is sort of saying, okay, it looks like there's a lot of bends, we'll multiply it by 1.4, or okay, there's a lot of bends, and I don't know where I'm going to park my truck, so we'll multiply it by 1.8 or 4. And they have no idea what their cost is going to be. And so the poor sheet metal contractor is like, sometimes their margin is 60%, and sometimes it's minus 30%, and they sort of hope at the end of the year, everything will work out to that 9% that was at the top of your diagram. There's no, like, buildings are so complicated and no one has any idea what's going on in terms of the cost, and like to be able to streamline things so that there's not, okay, like when you buy an iPhone, Apple doesn't like have no idea how much it's going to cost to produce. Like they know what it's going to cost to produce the iPhone, and like to move things to that sort of streamlined way is a really big deal in terms of the amount of waste of cost. And you know, you mentioned a lot of sensors. A lot of what we go and do is like fix the 200 different relays in the building control system that we're growing on. So the more that can be streamlined and eliminated and simplified, we make it more difference.
Erik, I want to talk about urban environments, because that's, you know, a sustainable place where we all should be living, where, you know, there's public transportation, there's walk, and yet from a building's perspective, it makes it very hard to reach net zero. How do you reconcile those two seemingly opposite things?
Yeah, I mean, I think dense building is where we want to go for a lot of reasons. We want to maintain agricultural land, we want to maintain open space, all that kind of stuff, reduce transportation costs. I I think ultimately it's sort of the point that I made earlier, that there are certain limits to how much energy we can produce on site, and that we need to develop regional frameworks so that we can provide for regional or district net zero energy production. And you know, there are some opportunities for efficient district heating and cooling systems. We'll need to explore those. But ultimately, I think we need to set up a market and a policy framework that will allow someone who wants to develop, wants to do the right thing in an urban environment to actually do it. And then beyond that, we'll probably need a regulatory framework that will ultimately require these things to happen so that there's a level playing field amongst all the people developing.
I'm glad you raised the issue of policy. That's obviously one big piece of the puzzle. And maybe Heather, you can weigh in with your experience from a legal perspective. You know, where are we, and is there any hope in the kind of government coming along and supporting what needs to happen to move us towards a more sustainable economy?
Definitely, I think so. I'm always an optimist, so you should take what I say with a grain of salt, because I will be optimistic. The federal government is probably not going to do anything dramatic on these fronts. There's activity at the state and local level, and that's been the story for many years now, that a lot of the innovation, the policy innovation, has been bubbling up, if you will, from the state and local governments, whether it's big city mayors in New York, San Francisco and LA, and other places, taking the initiative, or whether it's state legislatures passing legislation like AB 32, which is, for those who don't know, is the Global Warming Solutions Act here in California, and it's an economy-wide greenhouse gas cap that is really the only significant economy-wide greenhouse gas cap in the world. So it's very significant, and we'll have a cap-and-trade system effective on January 1st, 2012. It's obviously going to be phasing in over time, and probably won't have a direct impact on these issues that we're talking about for quite some time. But the policy environment is certainly moving, at least in California, in a direction that will be very facilitative to all the work that the panelists are doing, all the good work that they're doing. I'd be curious to see whether they agree with that in their day-to-day experience.
Yeah, I'm curious, does anyone feel the effects of that? Obviously, California is kind of leading the world in these issues, which is something to be proud of. But is there a filter-down effect that is helping you guys?
So we're super involved in policy. They help us out an enormous amount. Actually, one of the groups that does is PG&E, so the local utility. So we were actually talking about this before, but on how different utilities are in terms of their emission. But things PG&E does for our projects are they just pay us cash at the end of the project for the energy savings, and it's a lot of cash. A lot of times it will be up to 30% of the project. They loan us up to $100,000 at 0% money to pay for the project to get done. So a lot of what we do is we get competitive bids for construction and just pay for everything ourselves, and then we do investment through sharing the savings. So 0% loans is a big deal with that. And then they also probably a couple times a month will loan us $20,000 worth of equipment, which we can take to site and deploy and use. So that's been just an enormous help for growth. And so we literally looked at the amount of money we were getting from PG&E and then used it to hire another employee. And that happened within almost exactly 1 year of launching the company. And so to have PG&E doing this and then more states starting to pace, which Heather has been talking about, that's more very low interest money, which can really accelerate things. And so all of these policies that are moving forward, we actually participate in the cap and trade that's going on the East Coast, and we're very excited for the West Coast cap and trade to roll out so we can buy allowances out of it and essentially lower the cap. So all of these policies are just enormously galvanizing and helpful good policies.
I could add in there, from PG&E and the federal government, and NASA, since they have certain restrictions on what they can do, these kinds of spreadsheets, they've actually gone out through us, gone to PG&E, hired PG&E to do UESCs, utility energy service contracts, 20-year contract. PG is going to pay, they're going to pay us for the design, they're going to pay for the construction, and then they, PG&E over 20 years, will reap the benefits. So the federal government's not immune to this sort of thing. It's just a lot harder for them to get there sometimes.
Right, I should qualify by saying that legislatively, the federal government is not likely to move forward. There's a lot of things the executive branch can do. It is doing, there was an executive order that told every agency, basically reduce your carbon footprint, right? So that executive order is creating a marketplace for all these solutions that our panel is putting forward. The military has been very progress on this on a lot of different fronts. And so you look at this, the government, it's at a federal level or state level or local level. So it has three fundamental roles. Creates policy and regulatory environments that then drive a lot of these changes. It can directly finance through grants and loans, and it can be a customer, an early adopter, a customer, a proof point for a lot of these technologies. So I think that there are a lot of innovative policymakers in all levels of government that are really looking for ways to seize the opportunity to play that constructive role on one or more of those fronts.
I guess we have a little bit of a different perspective. I would agree that government's actually been pretty progressive, but we found that working with government is actually very, very painful for a number of reasons. The public sector is frankly backwards. And policy is slow. And so we think that really it's, you have to step beyond that. And it's interesting because this issue around the environment, and there are lots of worthy issues out there, sustainable seafood, or poverty, or developing countries, etc. But this issue is galvanizing some very smart, very rich people in this country in a way that other issues don't. And so there are actually an opportunity, this clean tech movement is really an opportunity that, thankfully actually has a chance of actually working, I think, beyond what policy can do. And, so we sort of, it's very important to us to make sure that our mission remains very focused on that. We have investors that are the same way. And I think that's a large part of what needs to happen is you actually do need people to step up and innovate. And so those of you in this room that are thinking about what to do, I think, you need to be thinking about what's the next idea I can bring. It may take 5, 10, or 20 years, but that's what is going to change things ultimately. In my belief, I don't believe policy will actually be the one that gets us there because it's driven by politics. Politics has too many vested interests, and it's not predictable.
Yeah, we'll be getting to audience questions very shortly, so I'm very interested to hear your kind of desires and want information and where you're kind of headed, because it's obviously a reason that you're here. But maybe we'll have a couple of last questions. I wanted to hear about, we spoke about the challenges and what are the ways to overcome those, but I'd like to hear about some of the biggest breakthroughs, some of the success stories that you can share. And I know that we're split kind of between new buildings and existing, so maybe we'll start with the kind of existing building side first and see maybe have a put up with anything that you can share some best practices or
I think PACE was a success story until it hit a roadblock, and hopefully it will pick up speed again on the residential side. And I'm really excited about what's going on the commercial side because it really, despite my optimistic view of kind of the good things that are happening on the policy front, speakers are correct. It's a very challenging policy environment. It's extremely unpredictable from an investor perspective. How do you model in, policy to, it's very hard. And there's an ongoing debate in Valley, in the venture capital community, about how to evaluate these clean tech companies that are in many ways strongly affected by policy that will need to have the ability to succeed despite where policy goes. So that being said, the exciting thing, one of the exciting attributes of a PACE type program is that it is focused on mobilizing private capital. It does not depend on taxpayer money. It does not depend on legislative wins going one way or another. And so the bringing on board the private capital and deploying it to is itself an innovation. It's financial innovation to hopefully help spread technical innovation.
Yeah, so I'm obviously a little biased, but I think it's a pretty big breakthrough that we figured out how to make it profitable for buildings to eliminate their carbon footprint. To my knowledge, that has never been done before, except maybe before we had energy. But in recent history, it's never been done. And so the ability to start a company that enables other corporations, and we can do this for basically any commercial or industrial building that's larger than 30,000 square feet, which is small. I mean, it's larger than like your average restaurant, but a 2-floor office building, a small 2-floor office building, basically anything that size or larger, we can eliminate the carbon footprint and make it profitable for the building. And I would say that's a pretty big breakthrough. And I think a lot of people say all you need to do is make it profitable and then it will just happen. It doesn't seem like that just happen part happens, but I think the fact that we've been able to demonstrate this model, I have a lot of hope that there will be a lot of other companies, and more profitable too. So my hope is that a lot of other companies will kind of notice this and start doing it and imitating us, and we can sort of build up an army of companies doing it. So I would say that is a breakthrough to actually get economics on the right side of the energy and climate crisis.
Congratulations on turning a profit so swiftly.
Oh, thank you.
Indeed. Actually, success stories in the show?
Yeah, I think I can give one sort of very small example, which is, on a building we're creating, the client wanted to have photovoltaics on top, and we did what we usually do, which is, we designed the four-part system. That's an option. We hand that over to the general contractor. They bid it. As usual, we see, Union Labor, San Francisco, small rooftop, some ridiculous price, and you're sort of like, well, that's sort of the going rate for doing this. I mean, we looked at it and said, well, we know that the solar panel costs X. It costs basically 25% of what the total solar cost is. So that's the biggest thing. That's what everyone focuses on. So why does it cost so much? So we looked at it and we said, it's probably, what it is it's exactly as Brenden said. You have these installers, they don't know what they're going to get. So they basically take an assumption to cover themselves. So we actually took responsibility for figuring out engineering. We created a system of attaching photovoltaics to our rooftops that we could repeat again and again, such that all the risk for the photovoltaic installer got taken out. All they have to do now is literally we give them the materials, we tell them the drawings, and they know exactly how to do it. They just put it on, and we saw that the actual price of installed solar dropped by about 40%, which is significant enough that it tipped the edge for several clients to actually do it with them. So, that's why I think there is opportunity here. And I sound like a broken record, but getting the economics to work is going to be the biggest thing that will turn climate change around in this country.
Tom, I'm interested to hear from you. You kind of collaborated too with many different parties.
Yeah, well, I think, my initial take, of course, was the big breakthrough to have windows that open was a big deal. Bill was done in the 90s. You might talk about this headline he made. Bill was done a design buildings with windows that open. Headline. So this is something he was working on a decade ago. But drawing back a bit, I think the fact that even though NASA is known for innovation and so forth, is the federal government, and the federal government tends to be very hidebound. I think the breakthrough was to do something that is so innovative and actually get it done and actually construct it, ready to be occupied in January. Kind of astounds me and makes me feel that, yes, this really happened in a good way. Even though, the road ahead is rocky, it's such a big step. I think it's going to, within the federal government, I think it's very important.
Yeah, not necessarily a personal breakthrough, but I think our industry has, over the last 5 or 10 years, with the advent of the LEED Green Building Rating System, started to adopt more integrated design practices, where LEED provided this framework for the architect and the civil engineer and the electrical engineer and the mechanical engineer and all of these people involved, the building owner and sometimes the building operators, to come together at the table and talk about something. And that has been a major breakthrough in achieving better buildings. And I think the net zero way would provide a similar sort of framework if we establish a net zero goal for this building. Okay, now we have a common goal and we each play a role, and that's been an important thing.
Great, well, I think we will turn it over to you. I'm sure you have lots of questions, so please feel free to put them over to our panelists.
Yes.
In the definition of net zero energy building, the construction process wasn't brought up, and I was wondering if some companies in evaluating whether their buildings are net zero energy, if they take into account the embodied energy in construction, because that's such a big chunk of that energy, and if NASA did that, and if the Project Frog, if that could, and other efficient resource construction methods could help buildings, integrate that factor into net zero.
I can start since you mentioned our project. Embodied energy was a part, but not a big part of our project. In terms of the amount of attention paid to it, obviously there are neat points to be gained by bringing in materials either constructed or resourced 500 miles, and we did that with our steel, for example. But it was more, I have to admit, in the case of this, more of a checklist thing than something that was front and center. And that
it's a great question about embodied energy. So when we talk about net zero declines, we actually don't take that into account just because it's a simplicity thing, because then you can get into, you include the energy of the construction workers in their Ford F-150s driving to the site from where they're driving from. It gets very complicated. And actually, analysis we did, which for a California code compliant building that was to basically stay in place for 50 years, the embodied energy, if it constructed with our method, would be about 10% of the total footprint of that building over its lifetime. That was our estimate. And about, the vast majority of it, about over 80%, 80-85%, was the actual energy consumption of that building during those 50 years. So what that said to us is, when we looked at all the materials, the biggest thing that we can do is basically work, we're okay to incur a bit more embodied energy if it actually would drive the energy efficiency of the building significantly. And so, we have this debate internally now. We use aluminum products in our building, windows, for example. It's a great product. It is one of the truest building materials you can work with. It makes very good seals. And that's one of the reasons it actually improves the energy performance. And the other thing is that there's a certain acceptability in certain commercial sectors that you couldn't just get away with like $5 a mile. So there's things like that that you have to be realistic about and say, well, as long as I can do that, I can trade that out because I can get the energy efficient down other areas. We find that works out. That's sort of the approach that we take.
Any other questions? Yes.
It seems to me that manufacture of pre-manufactured homes would be a ideal target to really scale up high-performance buildings. And when you look at was in Los Angeles area, how they manufactured in the 50s and 60s, 10,000s of homes of identical design. As someone who targets those companies.
Residential prefab?
Yeah, well, so we're in the commercial sector. There's sort of a number of pieces of that. But you're right, I think we agree with you. The point is this idea of where you can get repetition, what Thomas talked to, the complications of designing a building and getting the systems to work right, because it's different every time. You think through that once and you get it right, you repeat it, it's a huge opportunity. And it makes total sense, so we're in full agreement.
Yeah, and answer to that, there are companies, I live in Los Angeles, and there are prefabricated residential home manufacturers, and they build beautiful modern homes at a fraction of the cost of traditional homes. It's amazing, yeah, it's just a matter of getting the word out. I'm constantly surprised that not everyone is living in one. Yes?
I always thought there were a lot of barriers in the organized labor was pretty opposed to prefab construction, and anyone want to comment on that? And what would happen to our construction trades in this country if suddenly we were importing prefab buildings and cutting a lot of local people out of the market?
That actually has repercussions in the cost of conventional buildings in that, on a federal project, for example, there's a thing called Davis Bacon wages, which is any contractor working building for the government. They don't have to hire union people, but they have to pay them all equivalent wages to what the unions are setting. However, to the extent that the work can be done in a shop, that doesn't apply. So if you can design your building, have all the steel frames basically constructed in a shop and shop welded, you get actually better quality that way anyway, at lower cost per labor hour. there's an incentive to do that for that very reason.
You know, this interesting point is a little macroeconomic point about, well, if prefab succeeds, then you're going to put a lot of people out of work. It's the story of the Industrial Revolution. The industries have evolved over 150 years. You know, the auto manufacturing industry got mass production, it went through lean production, each time it's a massive step change, and it continues to improve efficiency every year. This is a macroeconomic issue about deployment of your resources in the most efficient way. And what tends to happen as step changes like this is you do get pools of unemployment. And that is where the policy to me is the most important thing, which is you've got people, they need to be reskilled. And so that's, you can't stop economic progress, right? If it's going to be fundamentally more efficient to make buildings and actually give people better, safer jobs in manufacturing environments, then that's actually the right thing to do, and then you need to deal with the consequences. That's how we would think about it.
Yes?
So I'm coming at this in part from a city planning and environmental planning perspective, and I'm thinking about whether there are some synergies with city planning that could help drive the adoption of more of these energy efficiency and carbon reduction technologies. For instance, an increasing number of cities these days are adopting green building ordinances, green design ordinances, and even cities that aren't, often there are projects that want zoning variances or want various consideration from local governments that may be highly receptive to proposals that show that the building will be energy efficient or green in various ways or net zero. So I'm just interested in any perspective on connection to local government initiatives.
Well, I could say one thing is just first do no harm, right? Don't get in the way of renewable energy projects. I mean, I know this is like residential context, right? Some neighborhoods won't let you put PVs on the roof because they don't like the look. You know, so zoning type regulations that are a barrier are things that we should try to get rid of. That's one thing.
So there's a lot of cities have been raising permit fees. So especially in California, where you can't really increase property taxes. So Prop 13 is the big thing for that. That happened way back when. So all these cities are out of money. They need to figure out a new source of revenue. So they've been raising fees like permits. And so you need a permit to put solar panels on your roof, and those costs have gone up. And sort of any modification that's major to the air conditioning system, those permits have gone up in cost. So they tie into the do no harm. But on the other hand, you know, cities need revenues. They provide services. So there's an interesting trade-off there. But in terms of city planning, so it can just make an enormous difference. So one thing you keep asking about best practices, so just point the house or the building south, like for the love. So we're in the northern hemisphere, the sun's in the south, like when it's summer it's really high, so you have a little awning and you don't get direct sunlight, the air conditioning use goes way low, light goes way down. And then in the winter the sun's lower in the horizon, the sun comes right in, it lights the building, it provides heat for the, just point the building south. Okay, you can't do that if all the streets run north-south and are close together. So if you just design the city so the streets run east-west and are like relatively close together that way and farther apart in the east-west direction, then any architect who doesn't even know about energy will start orienting buildings in the proper orientation. And there's a lot of small tweaks you can make like that, which I think would be very helpful.
White roofs would be another one.
Yeah, exactly.
One thing to add to that is that I know that a lot of cities are adopting you must be LEED Platinum or LEED Silver equivalent or Green Build, but they haven't quite figured out exactly how they're going to make sure that it happens. You can submit plans that theoretically conform to that, but in 3 years is the thing actually going to be performing to that level, and by then you've already picked up your deposit that you left assuring the city that you would meet this requirement or not, depending on how you did it. So it is another uncharted territory.
Yes.
I guess my question speaks both to Erik and Tom for what you've talked about. But prior to the advent of cheap energy, buildings were based on their environment were stylized to use less energy or to be comfortable. Right in the Southwest, you have Adobe because it's a great insulator in the extreme heat and cold. So my question for Tom, I guess, is does your practice consider regional sense of architecture in your design, especially based on where you're building? And then that also talks to just reducing the energy consumption of buildings overall. So Erik, what do you do, I guess, with energy efficiency and just reducing the electricity demand so that red line is easier to meet?
There's a regional considerations from the point of view of kind of architectural historical context. That's one, and then refer to the buildings. There's also, I mean, any architect designing buildings and meeting the professional standards of expectations will be taking the region into consideration and not just simply site adapting a cookie-cutter building. But when we first started this question, I was thinking prior to air conditioning, electricity, in say the late 19th century, many architects actually did what we consider sustainable design today by designing buildings that had natural convection and the screening of the southern sun and the western sun that Brenden talks about. So it's really expected that an architect will do that, to take into consideration.
You know, we've talked for a long time about energy efficiency strategies, and I think that fundamentally paying attention to kind of indigenous architecture, looking at passive strategies first, especially daylighting and natural ventilation where possible, solar peak gain control, so appropriate shading, appropriate orientation, thinking of daylight as the primary source of lighting, and basically say, well, we don't design a building that does not need an electric lighting system except when the sun goes down. Those sorts of strategies, just from architectural systems.
If I might just add to that, at NASA, we have a main office. My company has a main office within one of the NASA buildings. It's a 16 vintage concrete building with operable windows, but also with the kind of air conditioning. If there are operable windows, you can't operate it because people complain that the air conditioner will be going high volume mode. If you turn open the windows, suddenly everyone's freezing. So we got freezing air conditioning and space heaters going. It's an amazing burning of energy. And that happens whether the windows are open or not, by the way, just as a personal case. But there's that building. So the building could have been a lot better. Then we have an adjunct office across the way of the 1933 Shenandoah Plaza. It's an old Navy barracks, concrete building, very large, long building with narrow kind of bays. And there's no air conditioning outside of the window units people tend to put in. The building is designed with thick concrete walls and floors, thick backset windows, double hung windows. And I've been in there in the hottest days and taking advantage of the breeze off the bay. It's amazing what you can get by without air conditioning. That kind of building.
So I have a question. So one of the main things about buildings are the embodied energy, like materials like cement that are used in manufacturing. That's one part. So I wanted to ask how much of a part of the total energy of a building throughout its lifetime, say for residential and commercial, is the embodied energy. That's number one. And number two is when a building is being torn down, in a life cycle analysis, is the recycling of that material a significant possibility of improving that aspect of how to scavenge that material into your building, and that might decrease energy costs and CO2 costs there. And is there any opportunity that way?
So Ash, you had said where you guys found was around 10%.
Yeah, we did a full life cycle analysis on our building, assuming it was conventionally constructed. So over 50 years, about 90% of its footprint was the energy consumption, 10% was, I think about 85% was its energy consumption, 10% was embodied energy in manufacturing, and about 1.5% was the shipping of materials in the construction of the building. And then the remainder, which was about 4%, was basically the energy when you actually just dump it in landfill, assumed it will went to landfill. So, they are significant. And this building is one that has concrete in the foundation, it has steel, so it has some fairly high embodied energy materials. But we think there's too much of a focus, frankly, on embodied energy and on regional materials. We think that the regional materials in particular is just, it's sort of we think it's actually a bit confused. Because the materials don't actually come from where you think they come from. So it's just the way they've set it up to make the lead point system work, it's just biased. So in our opinion, there's not enough points in lead allocated to energy transfer and really making that building perform. Because that's, in our view, where the real benefit's going to come from over this life.
I'd say I agree with Ash. The focus on operational energy is the first priority, but I think ultimately these goals we're setting for ourselves as a society to getting to low carbon, we have to look at everything. We have to look at everything. And so the embodied energy we need to look at, deconstruction and the use of materials we need to look at.
Most steel these days is considered recycled. Concrete is we can specify added fly ash instead of normal aggregate. Those are the obvious ones. There are other more specific and idiosyncratic ones like and on the building I showed we're using some oak flooring that was saved out of the demolition of a wind tunnel. And the wind tunnel was meant as a heavy industrial floor, but it was good solid oak, and we managed to make it refinish and look like it should leave the living room. So there is some opportunity for recycling.
How are we going to time sit down? Is it maybe one couple more questions? Or?
Yeah, couple more.
Yes, couple more. So, bring gentleman in the black.
You all mentioned that the low energy prices in the U.S. is one of the big roadblocks. There are other countries in the world where energy prices are higher. In terms of kind of energy efficiency, are there other places that are not doing the right thing and not taking advantage of those higher energy prices, or places where actually energy efficiency is a bigger kind of sector and has made more progress than in the U.S. Because I feel like I don't really kind of get a good sense of the rest of the world just by
So I think there's a serious dearth of good energy engineers who are retrofitting. So as we talked about 80% of the carbon impacts and energy impacts are from existing buildings, not new construction. So a country like France, which is all nuclear power, has 40 cents a kilowatt hour power. There's islands which have 80 cents a kilowatt hour power. There's a lot of good architects. There's not a lot of good people who can go into existing buildings and fix them or operate the buildings well. And so Tom, you touched on this, having to retrain all of the facilities engineers at Ames. And I think there's a lot of opportunity that's been missed. And so we've been working with a company that consults with a lot of customers in China. And their biggest issue is they can't find the labor that can go in and identify the ways to really cut energy use. And so Erik mentioned this too. There's an issue in terms of training people to be really great energy engineers and go into a building and figure out an existing building which we can't rotate 90 degrees so it's south-facing, like how do we reduce the energy use. And so I think a lot of that missed opportunity has to do with the lack of really great labor that can do the analysis and figure out what you guys have different thoughts.
Yeah, unfortunately, I don't have a great perspective on what's going on in other parts of the world.
I have anecdotal only. I lived in Amsterdam 20 years ago, and I was kind of amazed at the sophistication of the window wall system with integrated blinds and louvers and all kinds of stuff. And I just and just reading my architectural press, it seems to me that first of all, Europe as an example is going to going to have a lot more existing building stock. That means the buildings are hundreds of years old, and they tend to value them highly. They're not seen as an investment for 30 years and then you tear it down and start over in many cases. So I think that there are things to learn on time.
Yeah, I'd second that. I think Europe and Japan, when we look at HVAC technologies, the dominant HVAC technology in the US is basically forced air. Right? You cool a huge chunk of air, you shove it around the building, great big ducts, and then where you need it warmer, you use reheat coils. So you're taking a ton of energy, you're cooling it, and you're heating up at the other end. It's like it's a double loss, right? And the dominant technology in Europe and Japan is variable refrigerant flow systems, where you're actually moving coolant around the building, moving refrigerant. And so it often happens you have one part of the building that's in the sun and it's hot early in the morning, and there's another part of the building that's cold, and that refrigerant is cooling down the hot part of the building, taking that heat energy and moving to the other part of the building that needs to be warmed up. And those systems are typically about 30% more efficient, and it's in over 80% of installations in Europe and Japan, and it's 3% of installations in this country. And to me, it's a combination of the price of energy. It's also the knowledge of the engineers and the installers putting it in. And it's also scale. There's a tipping point. So when it's at 3%, it's seen as a little bit of a premium item. It's seen as a specialty item. But once these things get over the hill pretty quickly, then it's like 30% energy saving in HVAC is not. It's actually pretty significant. So and for a technology that really doesn't cost any more than forced air.
We have time for one final question we've got here.
So when people are usually talking about generating energy for a building, they're usually talking about PV or solar cells, right? And as Erik pointed out, that kind of leads to the curve that you cannot have higher buildings. But have people looked into like using wind? I know wind is, they talk about big wind farms, which maybe at a domestic scale, small scale. And now if you have high rise, maybe putting out wind turbine on the top of a building could be, better than.
Yeah. There's a building going up in San Francisco. San Francisco Public Utilities Commission is building a building with some wind turbines attached on the side. We'll see how that works. There've been a few examples around the world where people have put wind turbines integrated into the buildings. They generally produce a very small fraction of the building's total energy use, and they're problematic in a number of ways. People are finding the vibration, the structural issues, the noise that they create has been a problem in many cases. And then the actual wind resource at that site. You need a lot of wind. The amount of energy produced from a wind turbine is proportional to the cube of the wind speed. So urban environments don't necessarily have the optimal amount of wind. But so far, building integrated wind has not been very successful. You probably could do it out in the country.
On that topic, there's also other, renewable energy like geothermal too. Often buildings tap that as a renewable energy resource.
Yeah, geothermal in the way, the context of buildings, it's usually like the system that Tom pointed out. It's a method of heat rejection. So we're just, instead of taking the air conditioner, instead of trying to reject heat to the air, we're rejecting it to the ground and get somewhat better efficiency. And that is what I consider a building efficiency strategy. That's and there's, maybe we'll get to the point where we're collecting methane off of our black water and our coffee grounds.
There is a technology to do that actually.
And that's another source of on-site.
And another category of generation, on-site generation, would be fuel cells. I think the blue box was mentioned, and combining power is a category that has some incentive in California to install that on buildings. But in general, this is one of the things that makes clean energy, clean tech so exciting and challenging is that in a particular region, some technologies are going to be great for generating utility scale power, like wind, and you charge a generator and generate electricity, you send it through lines just like you would natural gas power, and electricity, probably confusing the terms. Thank you. And then there's the on-site solutions and applications, and there's so many great ideas, and not just in the United States, but also internationally. I think this is I call it a multipolar innovation wave. This is not just coming out of Silicon Valley, it's coming out of many parts of the world, and it's being financed in many parts of the world. One bright spot I wanted to throw out there before we close is that in terms of investment trends, early stage venture investment in energy innovation is still very strong. And the third quarter results just came out. More than $2 billion globally going into clean energy companies, startups for early stage innovation. Most of the deals are in energy efficiency, most of the dollars are in energy storage. So there's that ways to think about.
I think a lot of the developing companies are going to define themselves on these new technologies. So we've got to act. I think on that note, we are going to wrap up. Thank you so much to the panelists for the deep dive into the subject. We really learned a lot. So I'd like to join me in thanking them.
So before we break for the networking
session, I'd like to take a moment to thank everyone who made this panel discussion possible. So first off, we thank everyone in the country. We have Shaya, we have CJ, and Philippe and Michael who aren't here presently, but you'll be seeing them shortly in the networking session. Secondly, we'd like to thank Rockford Capital who provided all the support and all the resources that made this panel discussion a success. We'd like to thank Sarah personally again for asking all the tough questions and sort of making the panel discussion as engaging as possible. Another note of thanks goes out to all the panelists for taking some time off and helping foster discussion on energy issues on campus. And finally, to the audience for actually showing up and making this conference a success. So on that note, we can move to the networking session. There's going to be sandwiches from Ike's and all the drinks. So those of you are hungry. It's just a few rooms down everyone.
Excited.
Thank you.